Okay, in this little video lecture, we are going to discuss about derivatives of inverse trigonometric functions. So we'll discuss through questions and answers. So problem, given that y equals to sine inverse of x, find dy dx. So solution. So the best strategy for you to be able to carry out the derivative, you change the function into the normal trigonometric function. So remember that y equals to sine inverse of x is the same thing as saying x equals to sine of y. So therefore now you have sine of y equals to x. So this is just a trigonometric equation. So therefore you introduce d dx on both sides. So d dx of sine y equals to d dx of x. So this is just the same steps we use when you're carrying out implicit differentiation. So when you differentiate a sine function, you get a cos function, but because there's a y, you attach dy dx. So y is a differentiable function of x, equals to d dx of x is just 1. And then remember that dy dx is the same as divide through by cos of y. So this expression. But remember, cos of, we don't want our derivative to be in terms of y. So recall this for the identity that cos squared y plus sine squared y is given by 1. So from this one, we have cos squared of y is given by 1 minus sine squared of y. So which tells us that now to get cos of y, you simply get the square root. So cos y is the square root of 1 minus sine squared y. So therefore now this equation becomes, so the place of cos of y, we write as the square root of 1 minus sine squared of y. But remember, from the word go, sine of y was given by x. So which means that then sine squared y will be given by x squared. So therefore, dy dx will be given by 1 over square root of 1 minus x squared. So this becomes the solution. Number 2, given y is cos inverse of x, dy dx is given by, so in a similar form, you change the function from being an inverse trigonometric function to a normal trigonometric function. So y equals to cos inverse of x is nothing but saying x equals to cos of y. So which is the same thing as saying cos y equals to x. So therefore you introduce d dx on both sides. So which means then when you differentiate a cos, you get a negative sign. But you remember to attach dy dx because y is a differentiable function of x, and then d dx of x is 1. So from this one, dy dx will be given by negative 1 over sine of y. But also recall that cos squared of y plus sine squared of y is 1. So which means that sine squared of y is 1 minus cos squared of y. So which means that then sine of y alone will be the square root of 1 minus cos squared of y. So this equation becomes dy dx equals to negative 1 over, instead of writing sine y, you write as square root of 1 minus cos squared y. But from the word go, cos y is x, so when you square it will be x squared. So therefore, dy dx will be negative 1 over square root of 1 minus x squared. And remember, for this denominator to be defined, then this must be less than 1. And then next one, given y is given by tan inverse of x, find dy dx. So as usual, you write y equals to tan inverse of x, means that tan y is the same as x. And then in this new trigonometric equation, you introduce d dx on both sides. Now you differentiate a tan function, you get a sec squared function, dy dx equals to 1. So dy dx would be given by 1 over sec squared y. And then you remember that your derivative must be in terms of x. So this is how you can change the equation in terms of x. You remember this identity. 1 over sec simply means we need to have divided by cos squared So from this one, here we have 1, sine over cos, we have tan, and then 1 over cos is sec. So which means that then this equation can be written as dy dx equals to 1 over, so the place of sec squared we write 1 plus tan squared y. But remember, from the word go, tan y is given by x, so tan squared y will be x squared. So therefore, dy dx will be 1 over 1 plus x squared. So this becomes the solution. And then next one, y given by cot inverse of x. So we write this one as cot of y is given by x, and then introduce d dx on both sides. Now we know that when we differentiate a cot function, we get a negative cosec squared function. Now you divide through by, so dy dx will be negative 1 over cosec squared y. Recall that cos squared y plus sine squared y is 1. So to get cosec, you need to have sine. So divide this equation by sine squared y. By doing this one, this will give us cot squared y plus 1 equals to 1 over this one will be cosec squared y. So therefore now, with this new identity, we rewrite our derivative as dy dx equals to -1 over, instead of having cosec squared y, we write cot squared y plus 1. But remember, cot is the same as cot y is x, so cot squared will be x squared, and then plus 1. So this is what we get. And then if we have y as sec inverse of x, then you write this one as sec of y equals to x. And then you introduce d dx on both sides. So this is what you have. So when you differentiate a sec, you get a sec tan function, and then you add dy dx equals to 1. But then you make dy dx the subject, will be given by 1 over sec y tan y. And then you remember that, recall that cos squared y plus sine squared y equals to 1. To get a sec, we need to have, we divide by cos squared, cos squared, cos squared y. So this one will give us 1 plus tan squared y equals to sec squared y, which tells us that then sec y alone will be the square root of 1 plus tan squared y. Or say same thing is the same as saying tan y is the same as square root of sec squared y minus 1, making tan squared tan the subject. This is what you get. So this derivative is the same as dy dx equals to 1 over sec y square root of, the place of tan we write sec squared y minus 1. So what is motivating us to express everything in terms of sec is because from the word go, we have an expression of sec in terms of x. This is where we came from. This is where we came from. So therefore, where the sec you put x, so dy dx will be given by 1 over, so x and then square root of x squared minus 1. So yes, the absolute value of x. So this happens when absolute value of x must be greater than 1. And then when we have cosec x, so y given by cosec inverse of x. So this is the same thing as saying cosec x, cosec y is the same as x. And then you supply d dx on both sides. So when you differentiate a cosec, you get a negative cosec times cot. So negative cosec y cot y dy dx is given by 1. So make dy dx the subject, the negative 1 over cosec y cot y. So recall that cos squared y plus sine squared y equals to 1. So divide through by sine squared y, sine squared y, sine squared y. This gives you cot squared y plus 1 equals to cosec squared y. So which tells you that cot squared y is cosec squared y minus 1. So cot y will be square root of cosec squared y minus 1. So therefore now this can be written as dy dx negative 1 over cosec y. The place of cot we write square root of cosec squared y minus 1. Now dy dx will be negative 1 over, so this one is the same as x, and then the square root of x squared minus 1. So also x must be greater than 1. So this is the solution to our, so this is how we get the derivative of inverse trigonometric function.